Have you got our poster scanned on now? Is that what?
No. This is
our slide.
Yes.
Okay, sorry. Okay, so we're from AWE. We work in manufacturing. At the moment, our company's going through a lot of site infrastructure change. We're building a few new manufacturing facilities. So we're using simulation modelling in our company to model both the existing facilities and the new facilities that we're going to be moving into, and the transition between the two. So it's manufacturing throughput that we're using. The idea was we wanted a lot of people actually on the shop floor to be able to use simulation modelling without a lot of training. So obviously, to use something like Witness or Simulate, you'd need a lot of training. So we got some consultants in to design a generic throughput simulation modelling tool that's based in Excel, and that actually interfaces with Witness. So they just have to use the Excel interface, and they'll be able to run the models themselves. That's about it.
Okay.
So next up is Han Jing from Loughborough University.
In case of my tongue twist, so I take the paper with me, sorry. Hi everyone, I'm Han Jing from Loughborough University. I'm a first year PhD student, and my topic is Optimized Police Patrol Officer Demand Modeling. And it aims at finding an optimal staff allocation to cope with the call for service demand from general public. When an incident happens, people will call in and wait for the officer's attendance. So queuing models could be implemented here to help analysis the service system. So the discussion will be centered on multi-server queuing model with time varying demand and the general service process. Some key features will be added in my model to ensure the model's feasibility. And the first one is two types of incidents will be discussed here, which require instant resource deployment. And they are emergency response and priority response. And the second one is the different targets for the different type of incidents inspire me to consider some other service disciplines instead of the basic first come, first serve discipline. I use the shortest remaining time first discipline for my model, and compare with the first come, first service, shortest remaining time first performs much better than within the same system configuration. Sorry. The last one is about the shift pattern. In the police force, patrol officers work on one of the 3 shifts a day, and the shifts.
10 seconds.
All right. The staff level will only change among different shifts. So I can see you can see there's a big advantage for time varying staff level than the constant staff level. And for more details, please see my poster. Thank you.
Can you kill that one, please?
Yeah, sorry. Next up is Tom from ORH Limited.
Okay, yes, I'm Tom Vaness. I'm here with my colleague John Mobbs, and we're from ORH Limited. ORH is a small management consultancy based in Reading, and we specialise in applying OR techniques to help resource planning in the public sector. We've worked in the ambulance, fire and police sectors, and I'm here to introduce ANTIM, which is our ambulance model. ANTIM is a discrete event simulator, and it's used to simulate vehicle responses to emergency calls throughout an ambulance service. It has to be able to output response times and vehicle utilizations, and we want to be able to use it to investigate how things like demand and dispatch protocols and vehicle deployments affect these key outputs. The model has to accommodate the fact that all admin services are different. They quite often have complex response decisions, response logic, and all their performance standards are different. The model is used both in ORH by our consultants, and it's also been deployed in ambulance services around the world, including the East of England Ambulance Service in the UK and New South Wales Ambulance Service. And here are two screenshots from the model. One is a map. You can't really see it very clearly. There is a copy of this on our poster showing the distribution of demand that's simulated, and here's a plot of, you can't really see it very clearly, utilisation over the space of a week of a vehicle at a station that's been selected here. You can see this characteristic heartbeat of utilisation going up during the day and dropping off at night. So yes, you can see these on our poster, and we also have the simulator on the laptop here. Thank you.
So next up is Ninette, also from Loughborough University.
Alright, good afternoon, ladies and gentlemen. My name is Ninette. I'm from Loughborough University, and I would like to tell you briefly about my research here. My research has to do with how does competition within and between supply chains affect supply chain collaboration and performance under different form characteristics. Here, basically, the questions is based on supply chain collaboration issue, because in reality, in fact, achieving the perfect collaboration is difficult, and a strong factor presumed hinder supply chain collaboration here is competition within and between supply chains here. Well, because the situation is complex, we are using agent-based model to model the interaction between firms to mimic the competitions here, and to understand how the effect of the competition towards supply chain collaboration and performance here. In other words, it's not only about agent-based modeling and simulation, but also about supply chain management. We are trying to analyze supply chain management issue by using agent-based modeling simulation. So for further discussion, just come and see our poster. And here's my poster.
Okay, next up is Joanna, also from Loughborough University.
Hi, I'm Joanna Lee. I'm also in my first year PhD at Loughborough University. My project is on police demand modelling and predictive patrol positioning to increase the efficiency of police resources. So this is very important at the moment due to the funding cuts the police are currently facing. And my simulation looks at producing dynamic patrol routes, which will vary with where each officer is and the area coverage and the crime trends at that time of day. And it will also look into selecting the most appropriate officer to then attend to these incidents, which can occur in the day. So looking at which officers are available and how close they are to the incident. So the aim is to find a way of testing to see what ways in which it can be optimised, the dispatch time, so the response time can be reduced. So my model consists of three main factors: a mapping tool, a routing tool, and a crime trend analysis tool. And the mapping tool helps locate the crimes and shows the roads in which officers can patrol on, and they can also be used to follow the routes to the incident. And the crime trend analysis model helps to pick out which hotspots are occurring at that time of day, and so then the routes, the patrol routes can be directed towards these to help deter crime in these areas. And the routing will help to find the shortest possible route and also the quickest possible route to get to an incident. So yeah, my simulation will look at testing different optimization techniques and hopefully find one useful for implementation in the business. Thank you.
And then we've saved the worst till last, which is me. Okay, so being as that I better stop time myself, hadn't I? Being as I'm excluded from the award, I thought I'd take the opportunity to insult everyone in the room. So I thought I'd talk briefly about academia and there's a general perception that we sit in an ivory tower, just doing very academic things, not really interested in the real world. This is actually a university with an ivory tower, a really fantastic university called Berkeley. So typically we're interested in methodology and looking at the field and where the field might be going and how we can add to that. So that's insulting academia. That's just insult industry. So this is industry. I'm pretty sure this is what people who work in industry look like. I don't get out from my ivory tower much. But what they're interested in is tools really to do their job and to do their job more effectively. And we know that there's it's a bit of a simplification, but we know that academia is keen to help industry adopt new methodology, and there's a bit of a time lag in that going on. And so occasionally people look at the field and try to get a feel for what are people using, what advanced methodology are people using, what software are people using. And there was some of this done in the early 2000s where they found that actually things like optimization and design of experiments isn't used very much in practice. So my poster is looking at the results of a survey specifically focused on search experimentation. So I'm talking about things like simulation optimization, design of experiments, and meta models. And what we were interested in is, to what extent are these methods used in practice? And I can say that some of them are used quite a lot now. But are they, a cynic would say, are these just limited to academic practitioners? So people with a strong academic background who work in an academic institution that are doing consultancy as well as methodology development. And what might limit the uses of these methods in practice? So come and talk to me at my poster if you want. And there's more results there. Okay, that's 2 minutes, exactly. So, can I thank our presenters? And the best way you can thank them is to go along to their poster and ask some questions about their work. Okay, that's it. Enjoy your coffee.